Welcome back, soldier. We're back in the matrix, and we're going to be talking about determinants. A determinant is a special number related to matrices, and it's a number that has a lot of different uses. And this special number is denoted by saying DETA, short for determinate A, or more commonly, you will see this, A with a couple bars on either side. It looks like the absolute value sign, but because we have a capital A, which represents a matrix, it changes its meaning to mean determinant. So we're going to look at determinants in a limited scope. We'll just be looking at determinants of 2 by 2 and 3 by 3 matrices, respectively. And the determinant of a 2 by 2 matrix, so if I was saying determinant of A, B, C, D, is found by this process, where we will multiply on the diagonal A times D, which will give us AD, and then we can multiply on the other diagonal, starting with C to B, which gives us this. And then we are going to subtract the two products, which will give us our determinant. Now, with a 3 by 3 matrix is a little bit more involved. So if we're trying to find a determinant of this general matrix, the first step you want to do is you're going to take the first column here and you're going to rewrite it here. And the second column, you're going to rewrite it on the outside of our matrix here. So once you've done that, you start this diagonal multiplication process once again. In this case, we'll multiply A times E times I, and we put that first, and then we start with B, multiply on that diagonal, and then C, D, H. And then you add all three of these together. Then you start multiplying on the upward diagonal, G, E, C, F, H, A, and then I, D, B. Then you add those terms together. Then, once you've added those products, the final step is you're going to subtract those two final sums. Now, let's actually try this and see what it looks like when we use real numbers. Okay, so we're going to evaluate each of these determinants. And we'll start with the 2 by 2. So we will multiply on the diagonal. So I'm looking for the determinant here, and I'm going to multiply 6 times -4 first, and that's going to go here as a -24. Then I'm going to multiply on the upward diagonal with +1 and -2. And that's going to go here. So that'll give us a -2. Recall, we're going to be subtracting. So we're saying -24 minus -2. In other words, -24 plus 2, which gives us a determinant of -22. Okay, now let's try the 3 by 3 matrix. So we're first going to start by rewriting the first two columns on the outside here. So 4, 1, 2, then -2, 1, 5. Now that we've done that, we can start multiplying on the diagonal. So let's see, make this equal. The first part, we will start with 4, 1, and 3, and we'll put that product first. So that's going to give us 12. Then we multiply downward on this diagonal, -2, -2, +2, so that's going to give us a +8. So remember, we're adding each of these terms, and 0, 1, and 5, which will simply give us 0. Then we're going to say minus, because remember it's subtraction between the first and the second one. And now we go on the upward diagonal. So now we do 2, 1, and 0, which gives us 0, plus 5, -2, and 4, which will give us -40. And finally, we multiply 3, 1, and -2, which will give us -6. So plus -6. Okay, so now we will simplify what we have. So 12 plus 8 gives us 20, minus, and then -40 plus -6 gives us -46. Remember, that's a minus sign in there, so we're going to end up adding these together. So that's going to give us 20 plus 46, which is 66. And that's our determinant for our 3x3. And that's all we need to know about determinants for now. In the next lesson, we'll discuss what matrices have to do with systems of equations. See you on the flip side.